And once you plug in all that and other information, make that 44/4 and do all the other stuff you have to do, you end up with -25/4 minus -81/4, which is -25 plus 81/4, which is just 14. All right, so any questions on that one? Straighten it up.
So basically, you do the antiderivative,
Mm-hmm.
and then you plug in.
Yep, you plug in the top number, and then you subtract after you plug in the bottom one.
So it's B minus A.
Yep, B minus A. All right. Oh, anyone's still writing? All right. So let's say, for example, we have the integral from 1 to 4 of 5t to the 3/2 power minus 9 with respect to t. Nope, bring that down a little bit. Okay. So again, we can just integrate them both together. Integral from 1 to 4 of 5t to the 3/2 minus 9 with respect to t is equal to, that would be just 5 times 3/2 plus 1 over 3/2 plus 1 minus 9t is going from 1 to 4. Okay, so it's 5 times t to the 5/2 over 5/2 minus 9t from 1 to 4. This one, if you multiply the numerator and denominator by 2 over 5, this becomes 1, so you end up with 5 times 2 over 5 times t to the 5 over 2 minus 9t. Okay, so those two cancel out. Uh-oh, I put 5 over 5. Should have been 5 over 2. Okay, so you have 2 times t to the 5 over 2 minus 9t. Okay, now we have t to the, make a little side note here, t to the 5 over 2, remember that's just t to the 1/2 times 5, which is just square root of t to the 5th power. Okay, so you can make that 2 times square root of t to the 5th power minus 9t from 1 to 4. Uh-oh, clean that up a little. Okay, so now you plug in your 4. So 2 times square root of 4 to the 5th power minus 9 times 4 minus, you plug in your 1. 2 times square root of 1 to the 5th power minus 9 times 1. Okay, so you have 2. Square root of 4 is 2. 2 to the 5th power is 32 minus 36 minus 1 to the any power is just going to be 1 minus 9. Okay, so we have 64 minus 36, which is 28, minus -7, which is 35. All right, so any questions on that one?
Do you go back up, or how do you get the 2 over 5 again from where you crossed it out?
Oh, because we just added 1 to the exponent.
Talking about down.
This one?
Yeah, how do you get from that to that?
Oh, because if you have, let me make a little side note there. So if you have t to the 5 over 2 divided by 5 over 2, if you multiply them both by 2 over 5 and 2 over 5, these two cancel out and just become 1. So you have 2 over 5 times t to the 5 over 2.
Oh, okay, yeah.
All right, does that make sense?
Yeah.
All right.
You kind of make the denominator 1.
Exactly.
You show up. Okay, got it.
Yeah, because if you try to solve it looking like that, it can make it harder than it needs to be.
So yeah, so you did it in the denominator, but if you do the denominator, you have to do it outside too as well.
Yep, so you just do that to both of them, that cancels out. And so really, anything, if you have a fraction in your denominator, you can just flip it and put it in the numerator. All right, any other questions on this one? All right. All right, anyone still writing? Nope. All right, so let's say, for example, if we have the integral from 4 to 9 of 3x minus 4 over square root of x with respect to x. Okay, so with this one, you want to get rid of that square root down there. And go from 4 to 9, 3x minus 4 over square root of x. Oh, move that up. With respect to x. You can make that equal the integral from 4 to 9 of 3x over square root of x minus 4 over square root of x with respect to x. Okay, which is equal to 3x, and the square root of x is just x to the 1/2 minus 4 over x to the 1/2 power. Okay, so we can combine these two. Make a little side note. So x, let's say x to the first power over x to the 1/2 power is just x to the 1 minus 1/2, which is x to the 1/2. Okay, so this just becomes the integral from 4 to 9 of 3x to the 1/2. Uh-oh, I'm about to put the parentheses on the wrong side. Minus, we can just make that a negative, 4x to the negative 1/2. And bring that up from the denominator.
You could have also brought up the square root of x as a, not a constant, but you can just multiply it instead. X to the negative 1/2.
Yeah, right, you mean rationalize the denominator?
Probably, yeah.
You could, but I don't think it would make it easier to
I mean,
integrate.
I came up as 3x to the 4th all multiplied by x to the negative 1/2, and then I just went to your step.
Trying to see, which part did you do that on again? I'm trying to picture what you
okay,
did.
so I got parentheses 3x minus 4
Mhm.
parentheses x to the negative 1/2, and then you would just distribute at that point. You should be able to distribute.
Okay, I see what you're saying.
And then.
Yeah, you could have done that.
Yeah, okay.
Yeah.
I just find it simpler to do that way. But yeah.
Oh, yeah, that works, then most definitely do that one. This is just one way of probably a half dozen that you can do these, if not more. Okay. So you have your integral 3 times x to the 1/2 plus 1 over 1/2 plus 1 minus 4 times x to the negative 1/2 plus 1 over negative 1/2 plus 1. And that's from 4 to 9. Okay, so you have 3, 1/2. If you make that 2 over 2, you end up with x to the 3/2 power over 3/2 minus 4, 1/2, negative 1/2 plus, you can make that 2 over 2, will give you positive 1/2. So you have x to the 1/2 over 1/2. Again, that's from 4 to 9. Okay, so if you multiply the numerator and the denominator by 2 over 3, you get 3 times 2/3 times x to the 3 over 2 minus 4, multiply both of these by 2 times 2 times x to the 1/2 from 4 to 9. Okay, these two 3's cancel out. So you have 2. And just a quick side note, x to the 3/2 power is just x to the 1/2 power times 3, which is square root of x to the 3rd power. Okay, so you have 2 times square root of x to the 3rd power minus 4 times 2 is 8 times square root of x. And that's from 4 to 9. Okay, so now we plug in our 9 first. So you have 2 times square root of 9 to the 3rd power minus 8 times square root of 9 minus, now you plug in your 4, 2 times square root of 4 to the 3rd power minus 8 times square root of 4.
Can you go off one line? Is that 8? What's inside that? Is that x to the 1 or is that
Oh,
just
this
the
one?
closing of your?
Oh yeah, that's just me closing
Okay.
out. Yep, the square root. I know sometimes I do it and sometimes I forget to do it.
I got a funny angle coming this way, so.
Okay, so we know that square root of 9 is 3. 3 to the 3rd power is 27. So you have 2 times 27 minus square root of 9 is 3. 8 times 3 is 24. Minus square root of 4 to the 3rd, well, square root of 4 is 2. 2 to the 3rd power is 8. Minus square root of 4 is 2. So you have 8 times 2. Guess you could have just put 16. Okay, so you have 54 minus 24 minus 16 and 16 is just 0. 54 minus 24 is 30. All right, so any questions on that one? All right, leave that up for a few more seconds. Oh, anyone still writing? Oh, all done? All right. Anyone still writing? Nope, like everyone's done. Okay. So we have the average value of a function. Okay, so the average value of a function is equal to, you have the integral from a to b of f of x with respect to x, but it's multiply 1 over b minus a. And I'll add the proof to the scanned notes. We can kind of, if you're interested in it, we'll kind of skip over it for time's sake. All right, so let's say, for example, what is the average value of f of x equals 6 over 7x plus 1 over the interval 0 to 7. Okay, so we already know that this is our A and this is our B. Okay, so your average value, why do I keep putting an E there? Average value of the function is equal to 1 over B minus A, so that will be 7 minus 0, times the interval from A to B of our f of x, which is 6 over 7x plus 1 with respect to x. Okay, so that's going to equal 1 over 7. Oh, why did I put A and B? I should have just put 0 and 7. Okay, so you have from 0 to 7, or the integral from 0 to 7. I might as well go ahead and just integrate it instead of rewriting it. Okay, so you have 6 over 7 times x to the first power plus 1 over 1 plus 1, plus the integral of 1 is just x, and that's from 0 to 7. Okay, so you have 1/7 times 6 over 7 times x squared over 2 plus x from 0 to 7. So you have 1/7, the 2 cancels out with the 6 there, and that becomes 3. So you end up with, say, 3 over 7, because they're not quite distributing yet, times x squared plus x from 0 to 7. Okay, so now we plug in our 7. Remember, that 1/7 is multiplied times that entire thing. So you have 1/7 times 3 over 7 times 7 squared plus 7 minus, now we plug in our 0, 3 over 7 times 0 squared plus 0. Okay, this just becomes 0, so that just disappears. So we have 1 over 7 times 3 over 7. You can leave that as 7 squared, because the minute you distribute, it's going to cancel out anyway. Uh-oh, forgot. Plus 7. No, I forgot something. And that's just 0, so you don't even have to count that anymore. Okay, and it seems like I'm missing something for some reason. Nope, I'm good. 3 over 7, 1/2, okay. Okay, so we have our 1 over 49 times 49. Oh, why'd I put 1? 3. Plus 7, which is equal to, I have a different answer for some odd reason. That's what I didn't do. Oh no, I have my 3. Nope, I did that. I canceled that out. 3 over 7. Oh, okay. Oh, I did it right. I don't know why I thought I messed up somewhere. Okay, so we have... No, I think I messed up somewhere, because I got a different answer earlier.
Well, you can't take the 2 from the...
1/7? You're factoring it out.
You did you not distribute the 1/7 to the other 7? Shouldn't that be plus 1 after you factor it? Once
That's
you
what I was
distribute
gonna
it?
say,
The 1/7.
So-
Plus 1, that's it, 1, okay.
That's gonna be
That's
plus
it,
The
1.
answer's 4.
Okay, I'm like, okay, I messed up somewhere. Okay. So... 7, yep, that's where I messed up. Okay.
Yeah, because you factored 7 over the 1.
I'm like, that didn't quite look right. There you go. Actually, I could have left that there and just left that as 7 times 1/7. Okay. And that cancels out. So you end up with 3 plus 1, which is 4. Okay. Actually did it different in my notes. Took the long way around. All right, so any question on that one? All right, so we're going to use that to find the mean value theorem for integrals. All right, anyone still writing? All right. So I might as well write it out since then substitute afterwards. So the mean value theorem for integrals. Okay, so let's assume that we have some function f of x is continuous on that same interval from a to b that we've been using all this time. Then there's at least one c value that is in between a and b. I might as well write it out like that. Well, I can just write it out. Where a is less than or equal to c is less than or equal to b, such that f of c is equal to 1 over b minus a times the integral from a to b of f of x. Okay, so there's at least one c value that's going to equal your definite integral. Or if you wanted to, you could write it, but you don't have to. But for the most part, you usually use this formula. But if you multiply both sides by b minus a times f of c is equal to the integral from a to b of f of x with respect to x. But for the most part, this is what you'll be using. Okay, which is the mean value theorem for integrals. All right, leave that up for a few. All right, so let's say, for example, let's say we want to find the value of c in the interval -6, 0, such that our G of C equals the average value. Of G of T equals negative 5T plus 9 over our negative 6 to 0 interval. Okay, so the first thing we're going to do is find the average value. Over your negative 6, 0. Where you know that this is going to be your A, this is going to be your B. Okay, so we know our average value of G is going to equal 1 over B minus A times the integral from A to B of G of T with respect to T. Which is 1 over B minus A is 1 over 0 minus negative 6 times the integral from negative 6 to 0 of G of T, which is negative 5T plus 9 with respect to T. Okay, so that ends up being 1/6. And if we go ahead and integrate that, we'd end up with, remember that's multiplied by that entire thing. You have negative 5 times T squared over 2 plus 9T, and that's from negative 6 to 0. Okay, so if we want to bring out that 2, we could, and just make it 1/6 times negative 5 over 2 times T squared plus 9T from negative 6 to 0. Okay, so first we plug in our 0. So that's 1/6. So if we plug in our 0, we have negative 5 over 2 times 0 squared plus 9 times 0 minus, now we plug in our negative 6, negative 5 over 2 times negative 6 squared plus 9 times negative 6. Okay. So the first one, that's 0, that's 0. So 1 over 6, just make that 0. You have 36. 36 times, well, 36 divided by 2 is 18. 18 times 5 is, I did that earlier, 90. So we have minus 90, so, oh, actually that would be negative 90, since you have a positive and a negative, minus 54. Okay, so that's 1/6. Negative 90 minus 54 is negative 144. You have a minus here, so that's positive 144. So you have 144 divided by 6, which is 24. Okay, so that's just your first step. Your second step, you have to now find of G of C that equals 24. Uh-oh. Find your G of C that equals 24. Okay, so our G of C is just our G of T, but we're going to change it to C. Kind of separate that a little bit. So your G of C